In today's video, we're gonna talk about authentication bypass and different ways website authentication methods can be bypassed, defeated, or broken. So these vulnerabilities can be some of the most critical as it often ends in leaks of customers' personal data. First one is username enumeration. So a helpful exercise to complete when trying to find authentication vulnerabilities is creating a list of valid usernames, which we'll use later in other tasks. So website error messages are a great resource for collecting this information to build a list of valid usernames. Let's try to do that on the website. So we are still working with the same website. So we'll go this time into customers and sign up. So if we try to put in a username that's probably valid or already exists, and let's try signing up. So when we try signing up with this username, it says already have an account, log in here. No, what it says is an account with this username already exists. So, which means we could try and use that to try and produce a list of valid usernames already signed up on the system, and this by using FAF. We used FAF tool with a list of commonly used usernames to check against for any matches. So let's open terminal. So this W switch for the word list that is going to be used for the fuzzing. So here we're searching for usernames. Then we're going to use a post method. So the argument -x specifies the request method that we'll use. So here it's a post method. Then D, so the switch D is the argument that specifies the data that we are going to send. So here it's username equal first, so that's what we're gonna first. Then email equal whatever, doesn't matter. Password equal same, doesn't matter. And C password. So how do we know the arguments that we are gonna send? It's here. And then when we sign up, you'll see here that there is the post. Do not save. There is the post here. And if we go to request, these are the information that we send. So username, email, password, C password. And so that's how we got all these parameters. Username, email, password, and C password. Then H. So to add additional headers, we'll add content type. -u for the target URL. And -mr, so to match to the regular expression. Here we are matching to the one that is here. Username already exists. Let's copy it. And launch it. As you can see, we have these username. So there is Robert, Simon, and Steve, and admin. So let's put them into a list. So we found admin. Here to verify. Here they are. So now that we have a valid username.txt file, a brute force attack is an automated process that tries a list of commonly used passwords against either a single username or a list of usernames. Let's use the valid username.txt file that we generated in the previous task and attempt a brute force attack on the login page. By the way, if you created your valid usernames file by piping the output from FERF directly, you have to clean your data or copy just the names into a new file. So let's just do that. So FERF -w valid username.txt. This one will be the first one. So we'll use two word lists. One is the valid username that we just created, and the second one is a word list. A word list for passwords, common passwords. So again, it's a post, so we are just doing the same as before. Just now, the username for the username we'll use w1, and for the password we'll use w2, the second word list. And this is for login, so we are trying to log in. We also have to put the content type header. So here we are asking, we use the switch fc or the argument fc to check for an HTTP status code other than 200. And by the way, just for you to know, we did the same as just before, like when we tried this command. So we went onto the login, we tried logging in, we looked at the network, the post packet, and we got the variables that were sent. Same with this content type, you'll find it also in the header, and we send. And here we have the password for Steve is Thunder. So now we'll talk about logic flows. So what is a logic flow? Sometimes authentication processes contain logic flows. And a logic flow is when the typical logical path of an application is either bypassed, circumvented, or manipulated by a hacker. So instead of going step 1 to step 2 to step 3 to step 4, we go from step 1 to step 4 directly. Logic flows can exist in any area of a website, but we are going to concentrate on examples relating to authentication in this instance because we are talking about authentication bypassing. So let's see an example. And as you can see in this code, this mock code, it checks to see whether the start of the path the client is visiting begins with /admin, and if so, there is further checks that are made, like in fact, is it really an admin? If not, the page if the page doesn't start with /admin, the page is shown to the client. However, because this PHP code uses these three equal signs, so equal, 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 it's looking for the exact match on the string, including the same letter casing. So an unauthenticated user that requests this, so /uppercase A, my lowercase d, uppercase m, n, lowercase, will not have the privilege checked. And that's a logic flow. So let's try it. We are going to try and reset the password function, like examine it, how does it work, if there is any flaw in its design. So let's go to reset password. So when we want to reset a password, as you can see, it asks for an account email. So an email associated with the account on which we wish to perform the password reset. So let's do a test email. Check email. So we can see that when we put an email that is non-existent, it says account not found from supplied email address. Let's say we found the email of the account for Robert, and let's see what is sent when we do that. So Robert at Acme IT support.hm, check username, and here we see the different things that were sent. In this post, we'll find every information we need to craft a curl command. So as we can see, there is the content type, there is also what else can we find in the request? So there is the username here, and we see the URL. Okay, so from this, let's open a terminal. Then in the header, we put the content type. We'll put it in application. And then there's data that we are sending. It's the username. And let's say it's Robert. As you can see, even though we have the email here in the URL and the username here. And it says, we'll send you a reset email to this email address. So now, instead of Robert's email, let's try and make it so it sends an email to us. So let's start by creating our own account. I just created an account, and when you create an account, I think it gives you an email. Yes, here you go. So it gives you this email. So let's use this email instead and try to see if we can change the password or if we can get access to Robert account. Okay. So here we go. And we'll craft the curl command. So you have to know something. It's the data are sent through a variable. Let's call it, it's the request variable. And it's this PHP request variable is an array that contains data received from the query string and post data. So from the query here, this part, and also the post data, which is here. So if the same key name is used for both the query string and post data, then the application logic for this variable favors the post data instead. So here we have the variable email. So we'll add this variable also at the end, and email equal. This time we are going to use our email. So I think it is. And then send it. So once we send it, let's see what it says. So as you can see here, we'll send you a reset email to the email I put in the post data. So let's go to the dashboard, and here we go. Password reset. Let's open it. And it tells us to visit this. To automatically log in as Robert. So who am I? Robert. And that's it. I just accessed an account which I wasn't normally allowed to access. And we can see the ticket where there is the flag. So here we go. So in this part, we are going to talk about cookie tampering. Examining and editing the cookies set by the web server during our online session can have multiple outcomes. For example, unauthenticated access, or access to another user's account, or even elevates our privileges. We have different types of cookies. Some cookies are plain text. So the contents of some cookies can be in plain text and it is obvious what they do. For example, if we see here, we get set cookie logged in equal true, and just under it, admin equal false. Using this logic, if we were to change the contents of the cookies and make a request, we'll be able to change our privileges. So we would be changing admin equal false to admin equal true. So first, let's start just by requesting the target page. Let's go back here and using curl. So cookie test. So it says the message is not logged in. Now we'll send another request, but with the logged in cookie set to true and the admin cookie set to false. So for that, we add the header cookie not the right code. And now it says logged in as a user. Finally, we'll try the same thing, but instead of admin equal false, we'll put admin equal true. And here we go, logged in as an admin. So we could do the same thing using the browser's development toolkit. Sometimes cookie values can look like a long string of random characters. So that is what we call hashes, and hashes are an irreversible representation of the original text. Here's some example that we may come across: MD5, SHA 256, SHA 512, and SHA1. We can see from the above table that the hash output for the same original string, which is the number 1, the hash output is different depending on the hash method that is used. Even though the hash is irreversible, the same output is produced every time, which is helpful for us as services such as CrackStation keep databases of billions of hashes and their original strings. So using CrackStation, we could put the hash in there and see what's the original string is, and if we can have an information that is easy to understand or easy to find and to understand, we can use that and change and temper the cookie like before, but modifying the value, then hashing it using the right hash function. Then there is also encoding. So encoding is somewhat similar to hashing in that it creates what would seem to be a random string of text. However, it is reversible. So what is the point in encoding? The point in encoding is to allow to convert binary data into human readable text. And that can be easily and safely transmitted over mediums that only support plain text ASCII characters. So common type of encodings are base 32, which converts binary data to the characters A to Z and 2 to 7. Base 64, which converts using the characters, so lowercase a to z, uppercase a to z, 0 to 9 plus slash, and the equal sign is for padding. So for example, let's take this cookie, which is set by the web server upon logging in. So what we can see here, it looks like an encoding in base 64 because it has like the equals padding, uppercase and lowercase letters and numbers. So if we take this string and decode and use like base 64 decoding, we'll find the value is ID1 admin false. So we can modify the admin value from false to true and then encode it back in using base 64 and send in the cookie like that. So that would give us an admin access. And that was it for today. Thank you for watching. I hope you enjoyed this video, and until next time, bye!